All right, so far in chapter 7, we've basically had two tasks. We've calculated confidence intervals, and we've figured out sample sizes needed to get a certain margin of error. So in 7.2, we did that calculated confidence intervals for proportions, and we figured out sample sizes for proportions, and there was a formula there for that one. In 7.3, we figured out how to calculate confidence intervals for means, and then also how to calculate sample size for mean, and there was a slightly different formula for that one. So today, to finish chapter 7, we're going to do the same thing for standard deviation. We are going to look at calculating some confidence intervals for standard deviation, and we are also going to look at doing sample size for standard deviation. And I think I'm just going to jump straight to sample size first and just get that out of the way. You remember the formulas from 7.2 and 7.3 are n equals e sub alpha over 2, p hat q hat over e squared. They're a little bit complicated. For sample size for standard deviation, the formula is, get ready, way more complicated. It's nasty, and you don't want to look at it. And the good news is you don't have to look at it. Instead, in the book, let's see, let's get rid of this junk. In the book, they have a table, and you'll just need to be able to read the table. So the sample size table in the book looks like this. And it's just set up for a very limited number of possibilities, right? So it either lets you do 95% confidence or 99% confidence, so just two confidence levels, and only certain margins of error, like 1%, 5, 10, 20%, and so on. And you can do this either for standard deviation, which is sigma. If you don't remember the symbols for population standard deviation, this is standard deviation and standard deviation squared. Do you remember what that's called? Yeah, right. That's variance. So we'll look at reading that chart when we get to an example from that. But for the moment, let's go ahead and just jump straight to a homework example. So this is number 12. And it says this data comes from Appendix B, but you don't actually have to look back there because they give you all of this summary statistics right here. There's a lot of numbers, so let me jump down to letter A and see what we actually need. Construct a 99% confidence interval estimate of the standard deviation of the pulse rates of men. Okay. So this is men, so let's see, we've got 40. Let's get on the right layer. So you've got 40 men, so that's probably going to be important. It is going to be important to say that the sample size is 40. And those men have an average of 67.3, and those men also have a standard deviation of 10.3. These are statistics from a sample, so I'm using S and X bar for the standard deviation and the mean. Okay, so let's, and 99% confidence, right? That's probably the other thing we need to know out of this particular problem. So let's go ahead and look at StatDisk. We kind of know the drill by now. So let's go to StatDisk and let's look at confidence intervals. And there's standard deviation for one sample. Okay, so let's remind myself of what numbers we needed. But look what they're asking for. Confidence level, sample size, sample standard deviation. Notice what they're not asking for. They are not asking for the mean, the X bar, which kind of makes sense, right? We're not estimating the mean. We're estimating the standard deviation. So maybe we don't need to know the mean. We just need to know the standard deviation. Okay, so let's dump our numbers in. We've got a 99% confidence. 99% confidence. Got a sample size of 40 and a sample standard deviation of 10.3. So we can go ahead and evaluate that and say the standard deviation is between 7.95 and 14.38. So 7.95, 14.38. You can say the standard deviation, the true standard deviation of the pulse rates of men is somewhere between like 8 and 14. Notice that's not talking anything about their average, right? Their average is way up here in the 60s. This is saying how much standard deviation is there, and about that much. We could do the same thing with women for part B. The only difference, let's see, is still 40. And those pulse rates have a mean, which we now know we don't need, and a standard deviation, 11.6. So let's just stat disk the same thing for women. Still confidence level 99, still sample size of 40, just a little bit bigger standard deviation at 11.6. So their interval is a little bit different to encompass their little bit different sample. So their standard deviation of pulse rates is between 8.95 and 16.20. Part C says compare. Is there a difference? And let's say not necessarily, right? There might be a difference, but it's certainly possible that the standard deviation for men is 10 and that the standard deviation for women is 10, right? That's within both of their ranges. It's possible that men are at 7.95 and women are at 8.95. There could be a difference, but there's no proof here of a difference. They certainly could be the same. So does there appear to be a difference? Not necessarily. Okay, so that was number 12. Let's move on to number 14. 14 similar, except they just gave us raw data instead of the summary statistics. So they do want a 95% confidence interval, and they want the estimate of standard deviation. We could use this same information to do a confidence interval for the mean, but be careful with what they're asking for, right? This is interval for standard deviation. So when the test rolls around, make sure you're doing the interval for the right parameter. Okay, so let's go back to StatDisk. And this time, instead of using summary statistics, which I don't have, I'm going to say use data. All right, so here's the point where you should put the playback speed to 2x, because I'm just going to type these numbers in now. 62, 61, 61, 57, 61, 54, 59. Ooh. Always check for typos. 57, 61, 54, 59, 58, 59, 69, 60, and 67. Okay, and I'm going to carefully look back through that list and make sure I didn't make any errors, and I think it's all right. Okay, so I did need 95% confidence, so that's good, and the data is in column 1, so I can go ahead and evaluate that, and I get my confidence interval for standard deviation right here. Say the standard deviation is somewhere between 2.9 and 6.9. Okay. So again, not a huge amount of variation in these speeds. They all seem to be pretty similar. The follow-up question here says, does the confidence interval describe the standard deviation for all times during the week? And these samples were all collected at 3:30. So Obviously, at 10 o'clock at night or at 3 in the morning, this could be substantially different. So yeah, this only represents traffic at 3:30 on weekdays. Yeah, it'd be different on weekends too. So they just want you to think about that a little bit and say, hey, if you gathered all your data at 3:30 on a Thursday for traffic, it doesn't necessarily represent traffic at midnight on a weekend. Okay, so let's look at one more example. Let's look at number 20. And 20 says you want to estimate the standard deviation, and you want to be 95% confident that it's within 20% of the true standard deviation. Find the sample size. Okay, so right here, we know we are doing a sample size question. So we're not actually getting a confidence interval. We're instead going back to that chart, and we're going to say this is how many people you should survey about their waiting times at McDonald's drive-up windows. So let's jot down the important bits. We're doing standard deviation, not variance, right? There's no squared here. Oops, no squared there. So we're not doing variance this time. The chart does include variance and standard deviation, but we're doing standard deviation. Okay, we want 95% confidence. So 95% confidence that we're within, there's our margin of error, within 20% of the true value. Okay, let's go back and see if we can find that chart, the sample size table. Let's see, let me actually turn this. Okay. So we want standard deviation. So we're on the left side of the chart over here for standard deviation. The right-hand side of the chart is variance. So standard deviation, 95% confidence. So we're in this top left quadrant of the chart. And we want to know within 20%. So sample size. 48, boom, that's it, we're done. No formula, no calculator work, that's it. Okay, so I think with those 3 examples, you should be set for tackling section 7.4. So go to it.